For almost all of human history, our biology developed under one specific, reliable source of energy, the sun. As it crests the horizon, flooding the landscape with light, it delivers a continuous balance of visible colors, ultraviolet, and deep infrared light. Our bodies are built to consume this sunlight. Our internal systems have a physical, biological requirement for this exact full-spectrum balance. That environmental baseline remained unbroken until the late 1990s with the mass adoption of the energy-efficient light-emitting diode, or LED. It was cheap, it used less power, and it quickly became the standard light bulb for the entire world. This chart compares the spectrum of natural sunlight to a standard LED. On the left, sunlight forms a smooth, continuous rainbow curve. On the right, the LED creates a massive spike in the blue spectrum, while the deep red and infrared wavelengths are entirely absent. We filled our homes and offices with these isolated blue-heavy lights. At the same time, we sealed ourselves behind modern infrared-blocking glass to control temperatures, effectively locking out the remaining red light from the outdoors. In the rush for energy efficiency, we inadvertently stripped away half the light spectrum our ancestors lived under for millions of years. Professor Glen Jeffery, a neuroscientist at University College London, tracks the impact of modern indoor environments on our health. His warning is stark. He points to the history of scurvy. Centuries ago, sailors suffered total systemic physical failure and bodily breakdown simply because vitamin C was removed from their diets. In modern times, humans are currently experiencing a similar nutritional deficit. We are living through a period of light scurvy. Professor Jeffery's research suggests that the systemic absence of red and infrared wavelengths in our daily lives is starving our cellular engines. Light is a forgotten, essential nutrient, one required to prevent systemic physical decay. To understand why light acts as a nutrient, we have to look inside the cell. These are mitochondria. They are the microscopic engines that produce ATP, the chemical fuel required for every single action your body takes. Mitochondria are light-sensitive batteries. They contain specific proteins, like cytochrome C oxidase, that are physically shaped to absorb light wavelengths. When deep red light, around 670 nanometers, hits this mitochondrial pump, the mechanical gears spin faster, outputting more ATP fuel. But isolated blue light from LEDs causes a different reaction. The harsh blue wave makes those gears stutter and slow, drastically dropping energy output. When researchers tested this blue light stress in animal models, they observed a specific set of consequences: chronic fatigue, systemic inflammation, and elevated blood sugar. Bathing in isolated blue light while starving ourselves of red wavelengths actively drains our cellular batteries, driving modern metabolic dysfunction. Professor Jeffery's clinical research reveals a specific requirement for this light. It only triggers these biological changes if it is delivered at an exact time of day. This is the reality of circadian chronobiology. Your mitochondria have shifting daily workloads. They operate on a strict internal clock and aren't equally receptive to light at all hours. Mitochondria are perfectly primed for a biological jumpstart right at the beginning of the day. This makes morning light exposure uniquely critical for cellular health. In the lab, delivering the exact same red light treatment in the afternoon or the evening produces zero measurable benefit. The cellular engine simply isn't in the correct phase to receive it. Biological light nutrition depends on delivering the right wavelengths exactly when the cellular engine is programmed to absorb them. To see the impact of targeted morning light on a human scale, we must look at the most energy-hungry tissue in the body, the retina. Because of its massive energy demand, the retina fails rapidly as mitochondrial efficiency naturally declines with age. The photoreceptors simply lose the power they need to function. Professor Jeffery's clinical trials found that exposing older patients to just 3 minutes of deep red light in the morning reversed this declining eyesight. This chart tracks visual acuity over time. After the morning treatment, that natural downward trend spikes back upward. Patients experienced up to a 20% improvement in their color contrast sensitivity. The duration of the effect was equally surprising. A single 3-minute biological recharge lasted for an entire week. We have clinical proof that this form of aging is not irreversible decay. It is an energy deficit that can be corrected with the right light. This effect extends far beyond the eye. When mitochondria in one area are stimulated, they signal to the rest of the body. The entire body's metabolism shifts in response, a phenomenon known as the abscopal effect. As the recharged mitochondria spin faster, their fuel demand increases. To keep pace, they actively pull excess sugar out of the bloodstream. This graph illustrates the results from Jeffrey's human metabolic trials. The tall spike shows a standard blood glucose reaction after consuming sugar. The significantly flattened curve shows the same test performed after a brief exposure to red light. We have the power to reclaim our natural environment. Whether you replace your LED bulbs, use targeted red light therapy, or step into the morning sun, you're fixing a biological deficit. Light is a forgotten essential nutrient. Consume it correctly, and your body has the energy it needs to survive.